Hey guys, let's get started with our bell ringer. You have two problems to do. You have to simplify the radical, the square root of 112k cubed, and then you need to write the equation on a line that passes through the following 2 points. So through 0, -2, and -5, 2. For the first problem, you have to remember make the factor tree, look for your pairs, and pull out your pairs. For the second one, use your slope equation. M equals y2 minus y1 over x2 minus x1 to find your slope. Then use that in y equals mx plus b to write your equation. So go ahead, take a couple minutes, work through the bell ringer, and when you're done, we'll pause the video first, and when you're done, unpause it to get your solutions. So the solution to the first problem is 4k times the square root of 7k, and the solution to the second problem is y equals -4/5 x minus 2. Today we're going to go over 8, 7 multiplying and dividing roots. So what I want you to do is work through this page first. I want you to multiply the following roots using your calculator. So take your calculator, punch in root 6 times root 24, figure out what that is equal to, and then find out what root 2 times root 98 is equal to. Then I want you to multiply the numbers underneath the roots first, and then take the square root of the number. And then once you do that, I want you to see if you can write a statement about what you think we're allowed to do when we multiply the square root. So take a couple minutes, do this part of the notes, unpause the video to get the solution. So go ahead and pause the video now. So when you use your calculator, you should have gotten 12 and 14. Now when we multiplied first, what is underneath the root, you should have gotten root 6 times root 24 is equal to root 144. And we know that the root of 144 is 12, which is what we got before. And you look at the second one, we have root 2 times root 98, and multiply what's underneath the roots, which is root 196. That is equal to, and the square root of 196 is equal to 14, which is what we got before as well. So when we need to write a statement about what we think we're allowed to do, we multiply square roots. You notice that you can multiply what is underneath the roots. So we can multiply what is underneath the roots and then solve. So to multiply square roots, multiply the numbers underneath the radical. So for example, if we have root 2 times root 3, well, that is equal to root 2 times 3, which is equal to root 6. Looking at the next one, we have root 2b cubed times 4 root 2b squared. We'll take this 4, we'll bring it out front, we'll leave it out in front of our radical, and we'll take 2b to the power of 3 times 2b squared, and we'll take the square root of all of that. Now we can do some multiplying. Since we are multiplying bases, we're going to add our exponents. So we'll take our 2 times 2, which is 4, and our b to the power of 3 times b squared. Add our exponents is b to the power of 5. And now let's go ahead and simplify a little bit. 4 is equal to 2 times 2. That's a pair. b to the power of 5 is b times b times b times b times b. We have 2 pairs of b's. So that means we can pull out a 2 and a b squared, and we'll be left with a b underneath. And then one last step, we'll have 8b squared root b. And the last one, we have 3 root 18x cubed times 4 12x squared. The first thing we're going to do is multiply our 3 by our 4. That'll give us 12. and then we'll multiply what is underneath each of the radicals. So we'll have 12 times 18 times 12, which is 216. Then x to the power of 3 times x squared is x to the power of 5. Let's go ahead and simplify what's underneath our root. 216 will break up into 6 and 36. And we know that 36 will go into 6 and 6. And then x to the power of 5 is x 5 times. Remember, with square roots, we're looking for, I have one too many x's there. Square roots, we're looking for pairs. So I have a pair of 6's here, and two pairs of x's. Since I have a pair of 6's, I can pull out 1 6, and I have two pairs of x's, so I'll pull out 2 x's, or x squared, and I'll be left with a 6 underneath and an x underneath the radical. And then we just have 12 times 6, which is 72. So our final answer would be 72x squared root 6x. So go ahead, pause the video, work through the huddle, and when you're ready for the solutions, unpause the video. So here are all the solutions to the huddle problems. Go ahead and check out the answers. Pause the video if you need to, and whenever you're ready, go ahead, unpause it, and move on. For this slide, you're going to do the same thing you did before. Use your calculator first, then divide what's underneath the radical first, and then calculate. And then once you do that, I want you to write what you think we should do when we divide. I'm sorry, this should be when we divide square roots. So go ahead, pause the video, work through this little exercise, and when you're done, unpause it, get the solutions. So when you divide with your calculator, you should have gotten 1.73 and 2.24. Now, whenever you divide what is underneath the radical sign first, you'll have root 12 over 4. Well, 12 divided by 4 is 3, and root 3 is also 1.73. And then you also have root 20 over 4. Well, 20 divided by 4 is 5, so we'll have root 5, which is also equal to 2.24, so the same as we did before. So, what we're allowed to do when we're dividing square roots is we can divide what is underneath the radical. We can divide what's in the radical. So we now know when dividing square roots, we can divide what is underneath the radical. So we have the square root of 8 over the square root of 2. We know it is the same as the square root of 8 over 2. Well, 8 over 2 is 4, so we'll have root 4, which is just 2. Looking at 5 times the square root of 15 over 3 times the square root of 3, that'll just be 5 over 3 times the square root of 15 over 3. Since 15 divided by 3 is just 5, our final answer will be 5 root 5 over 3. The last one, it's a little different. We have some variables included here. Still, just take the square root of the whole thing divided, so 20 x to the 5th y to the 3rd over 5x to the 4th y. Go ahead, divide 20 over 5, which is 4. X over 5, x to the power of 5 divided by x to the power of 4. We know we're supposed to subtract our exponents. 5 minus 4 is 1, so we'll just have x. And then we have y to the power of 3 over y, which will be y squared. So we have the square root of 4x y squared. 4 breaks up into 2 times 2, and we have y times y. So we have a pair of 2's, a pair of y's. We can pull each of those out. So our final answer will be 2y times the square root of x. So go ahead, take a few minutes, work through these 3 huddle problems, and whenever you're ready, go ahead, pause the video. When you're ready, unpause the video and get the solutions. So here are the solutions to the huddle problems. Go ahead and take a look, pause the video if you need to. When you're ready to continue, unpause, and we'll move on. So let's talk about the Pythagorean theorem a little bit. We've seen the Pythagorean theorem before. You should have seen it in 7th grade. So with the Pythagorean theorem, in any right triangle, with the legs of lengths A and B, so like the triangle below, it has legs that have a length of A and a length of B, and a hypotenuse, all a hypotenuse is the longest side of a right triangle. So we have side in a right triangle with legs of lengths A and B and a hypotenuse of length C, then we know the Pythagorean theorem will work. And that is a squared plus b squared is equal to c squared. So we are going to use that equation to find the length of the missing side of the right triangle below. So we have side lengths of 2 and b and a hypotenuse of 4. So using our formula, a squared plus b squared equals c squared. Well, we know a, that is one of the side lengths. That is 2 squared. We don't know the other side lengths. That'll be b squared. But we also know the hypotenuse, which will be 4 squared. Go ahead and do some squaring. 2 squared is 4. So we have 4 plus b squared is equal to 16. Subtract 4 from both sides to get b squared alone. Well, b squared is equal to 12. Now let's talk about how to get rid of a square root. Well, the inverse operation of squaring something is taking the square root of it. So to get rid of that square, we're going to take the square root of both sides. So b is equal to the square root of 12. Let's see if we can simplify root 12 at all. 12 goes into 2 and 6, and 6 goes into 2 and 3. We have a pair of 2's, so I know I can pull that out. So b will be equal to 2, and we're left with just a root 3. So b is equal to 2 root 3. So now I want you to work through this problem. Go ahead, I want you to find the exact length of the missing side of the triangle below. Use your Pythagorean theorem. Notice that the hypotenuse is missing. So go ahead, pause the video, work it out. When you're ready for the solution, unpause the video. Alright, so the solution to this missing side of the triangle is 7 root 2. So that is the end of our lesson. Go ahead and ask the sub for your homework. It is worksheet 878. You're going to do 1 through 16. Good luck.